Welcome to this explainer. Today, we're doing something a little bit different and honestly, a lot of fun. We are going to methodically unpack exactly how AI agents work, why they are completely flipping the script on traditional software, and then we're going to immediately lock in that knowledge. We've built an interactive masterclass here, complete with a rapid-fire quiz where you'll get a few seconds to test your grasp on real-world scenarios. So if you want to understand the actual mechanics of the future, you are in the exact right place. Let's dive in. Here's our game plan for today. 1. What is an AI agent? 2. How agents think. 3. Our interactive knowledge check. 4. Advanced agent scenarios. And 5. A final summary and takeaways.
All right, part 1. What is an AI agent, and how are we moving beyond fixed rules?
Think about that word, brain. At its core, an AI agent is an autonomous system that uses a large language model, an LLM, as its central processing unit. But, it's not just sitting there generating text. It actually has the autonomy to control and decide the flow of a task. It does this by utilizing specific tools, things like running web searches, making API calls, querying databases, or even managing file systems. The agent evaluates its objective, fires off these tools, and clearly defines for itself when the workflow is actually complete. This really highlights the core difference. Normal workflows, they're totally deterministic. Think of a standard marketing pipeline. A user submits a form, the system generates a PDF, sends an email, waits exactly 2 weeks, and sends a follow-up. It's all predefined, fixed, if-else logic. An AI agent, on the other hand, is non-deterministic. The LLM dynamically decides the next steps. It's literally the difference between a fixed train route and a smart GPS. If a smart agent realizes it already has the information it needs, it can just skip the unnecessary steps, dynamically adapting its plan to reach the goal faster. Moving on to part 2, how agents think, specifically looking at the ReAct pattern and memory. So the absolute crucial concept here is the ReAct pattern. Reason and act. It's the very heartbeat of an agent's problem-solving loop, and it works in 3 distinct phases. First, thought. The agent analyzes the user's natural language query and formulates a plan. Second, act. It executes an action by calling a specific tool. Third, observation. It pauses to ingest the actual, real-world result returned by that tool. Then it reflects on that observation and loops right back to a new thought. It's this continuous, non-deterministic loop of thinking, acting, and observing until the final output is fully ready. Now, to keep track of all this looping, the agent desperately needs memory. We're looking at 2 types here. Short-term memory is session-based. It lives entirely inside the current conversation's context window. Think of this like notes written on a classroom whiteboard. It's incredibly useful for the current task, but the risk is, if the conversation gets too long, the whiteboard fills up, and older context just gets erased. Long-term memory, however, persists across entirely different sessions, which allows the agent to recall facts and user preferences days or even weeks later. Okay, part 3. This is our interactive knowledge check. I'm going to throw a scenario your way, read it out loud, and give you 3 seconds of silence to lock in your answer before we break it down together. Let's see how well you grasp these concepts. Ready? Here is your first scenario. Say a system always searches a knowledge base, dumps the results into a fixed prompt, and spits out an answer. The LLM never decides whether to search or skip searching. Is this system an AI agent? 3, 2, 1. The answer is absolutely no, because the steps are hard-coded by a developer. This system lacks autonomy over its control flow. Think of it this way. A washing machine always follows the exact same cycle no matter what you put in it. That's a pipeline. A human laundry expert who looks at a silk shirt and dynamically decides, okay, this needs to be hand-washed, has autonomy. An AI agent has to be the laundry expert, not the washing machine. All right, next question. Check out this repeating pattern. Thought, then action, then observation, then thought, action, observation, leading to a final answer. What specific style of reasoning does this represent? 3, 2, 1. If you said the ReAct pattern, you hit the nail on the head. Notice how ReAct actually interleaves internal thinking with real-world tool use. It's exactly like a detective thinking about a case, going out to check real fingerprints in the field, and then thinking about that new evidence. Chain of thought, by contrast, only thinks internally. That's like the detective trying to solve the entire crime just by sitting in a closed room without ever looking at external evidence. Okay, moving to our third scenario regarding tool usage. The LLM outputs a JSON payload formatting a command to execute a specific SQL query on a database. Who actually runs that SQL query? 3, 2, 1. The answer is your application. Your code runs it, not the LLM. The LLM only proposes the function call. Think of the LLM as a manager who writes an email saying, "Please order 10 laptops." The manager doesn't actually pull out a credit card and buy them. The purchasing team, which is your application code, is the one that actually executes the order. This separation of powers is absolutely critical for the security and architecture of your software. Section 4. Advanced Agent Scenarios. Let's look at scaling architecture and security. So when tasks get crazy complex, a single agent just gets totally overwhelmed. That short-term memory whiteboard we talked about, it fills up way too fast. Enter multi-agent architecture. Instead of one student trying to research 5 different topics in a single notebook until they run out of pages, we use 5 specialized students, each with their own notebook, guided by a leader. An orchestrator agent acts as the main controller, delegating tasks to highly specialized sub-agents like a SQL agent for database queries, an analysis agent for crunching numbers, and a visualization agent to draw graphs. This totally avoids context bottlenecks and allows for really powerful parallel exploration. Let's do one final knowledge check, and this one is all about security. An agent system prompt strictly says, "Only allow select queries." However, the SQL tool itself is programmed to execute whatever query it receives. A clever user tricks the LLM into generating a drop table statement deleting your data. What is the core security gap here? 3, 2, 1. The answer? A massive gap in defense in depth. Look, the explicit rules in a system prompt are great for giving the LLM a safe persona, but remember, they are probabilistic. They can be bypassed by clever users. The tool itself absolutely must have hard-coded validation. A system prompt is essentially a helpful sign on a door saying, "Do not enter the server room." That's nice and all, but to truly secure the system, you still need a locked door with a keycard. And that means hard-coded validation sitting right inside your application tools. And finally, Section 5, our final summary and takeaways. Basically, your AI agent cheat sheet. Honestly, feel free to pause the explainer right here and grab a screenshot. This perfectly summarizes the core mechanics of AI agents we've talked about today. If you're wondering if a system is an agent or a pipeline, just ask, who decides the next step? If you want to know the value of dynamic planning, ask, can it skip unnecessary steps? Always remember that ReAct is the vital think, act, observe loop. Multi-agent systems thrive as a team of specialists under one coordinator. And for sure, always secure your systems with defense in depth, combining soft persona prompts with hard-coded tool validation. I'm going to leave you with this final thought to ponder. We've relied on fixed, predictable, if-else logic practically since the dawn of computing. But as AI agents become more autonomous, more reliable, and capable of actual collaborative multi-agent teamwork, are we currently looking at the end of traditional hard-coded software as we know it? It is a wild paradigm shift, but now you know exactly how the foundation of that shift actually works. Thanks so much for joining me on this explainer, and keep exploring.